Okay, this question clearly involves trigonometry, and there are basically two trigonometry rules that you need to know for the SAT. That's way less than you need to know for the ACT, right? So the ACT has lots of trig. The SAT is pretty simple, and if we know the second rule, the one that's used less often, we can get this question right in 3 seconds. I'm going to use the first rule, though, to show you and kind of lead towards the second rule. So what might I do? Well, I know that there's a little bit of memorization that has to happen with trigonometry, right? I need to know SOHCAHTOA, right? That's the mnemonic device that we use to remember what sine, cosine, and tangent mean. So in this case, I see that I have sine, and I know that opposite over hypotenuse has to do with the sides of a triangle, but I don't see a triangle, so maybe I should draw one, right? So let's do it. So here's a triangle, right triangle. And the sine of x, let's just put it here, is equal to the opposite side divided by the hypotenuse. So the hypotenuse then has to be 5 to match up. And remember, the opposite side is across from the angle, so that means that that's 4. Now we could do Pythagorean theorem to find the other side because we have two sides of a right triangle. That means we could find the third, but hopefully you've memorized that 3, 4, 5 is a very common triangle. It's a special Pythagorean triple, and so it comes up a lot in trigonometry, and especially on the SAT where we don't have a calculator, so weird numbers aren't going to fly here. We need normal numbers. Now we get to this other piece, though. What is cosine of 90 minus x? That's kind of weird. But if we know how triangles work, we've got this answer. Because there are 180 degrees in a triangle. Because it's a right triangle, we've got 90 of those degrees locked up, leaving 90 left for the other two angles. And in this case, we don't know what x is. But if we were to continue this little pattern here and try to figure out the remaining angle, we would subtract x, whatever number it is. If it's 40, we would subtract 40 and we would get 50, right? If it was 10, we would subtract 10 and we would get 80 as the other angle. And so no matter what x is, the other angle is going to be 90 minus x. So I can write that in there. Now going back to SOHCAHTOA, cosine is the adjacent over the hypotenuse. The hypotenuse is still 5, and the adjacent side is the one that isn't across, right? Is that the side that makes up the angles. The hypotenuse is always opposite the 90-degree angle, so that's consistent. Opposite and adjacent are going to kind of flip around depending on where we are in the triangle. And so in this case, the adjacent side is 4. So the cosine of 90 minus x is 4/5. Which is weird and kind of upsetting because we don't like that the answer is actually the thing that was in the question. That's like really weird. But that happens a lot with trigonometry, mostly because there's only so many combinations of sides, and so it's likely that the numbers that appear in the question are going to kind of reappear in the answer. So don't let trigonometry mess with you that way. But it's especially likely because even though we knew this first rule and did a lot of stuff to prove that it's the same number, we could have skipped all that because the other trigonometry rule would have just told us that this was going to happen from the start. The second rule, the only other trigonometry rule that we really need on the SAT, is this formula. The sine of x is equal to the cosine of 90 minus x. Or we could flip it. We could also say that the cosine of x is equal to the sine of 90 minus x. So there's this weird kind of relationship between cosine and sine. And so if we knew that from the start, right, if we knew we have sine of x and we're being asked for cosine of 90 minus x, we know that it's going to be the same because of this rule. So we could have, without showing any work, have just come up with 4/5 very confidently if we memorize this rule. So hopefully now you understand it and you know it's there. But I do think it's helpful to see why it's true. I think it helps you memorize it. Because it seems scary when we look at it, but if we see it happening on the triangle, it makes a lot more sense. Really what this second rule is saying is that the opposite for one angle is going to be the adjacent for the other. Because in a triangle, in a right triangle, there's only really two angles that we care about. And opposite and adjacent are based on perspective. So the opposite of one angle is the adjacent of the other. And so that's what this second rule, this second formula is really telling us. And so that makes total sense, right? I mean, we can see it very clearly in the triangle that we're talking about the same side, even though we're starting from a different angle. And it just works out nicely. So if you've done trigonometry in school, there are a lot of formulas that they throw at you that you have to memorize, and your teachers don't always explain the origin of the formula. And I kind of get it. It's complicated, and sometimes you just need to memorize stuff. But here's a case where I do think that explaining it makes it easier to memorize, and if you are stuck on a question that uses this formula, odds are good you can just use SOHCAHTOA and do it a slightly longer way, but prove your answer using the triangle and the picture of the triangle. So either way, push through, be confident with SOHCAHTOA and trigonometry, and this kind of stuff won't scare you when you encounter it on the test.